All right, so like I said, this second part of the third section of chapter 7 is a little strange, but it's just introducing some different concepts. We have worked with sine and cosine before when we were solving right triangles, right? Like if we have practice using trigonometric ratio to find side length and angle measures in right triangles, okay? So the laws of sine are going to show a proportional relationship. So we're just going to be setting up proportions, and I think you guys are pretty good at that, between angles and their opposite sides. It can be used to find side lengths and angle measures for any triangle, okay? Now we're not talking about right triangles. These are not right triangles. They're just any old regular triangle. So here's like the generic formula of how the ratio works. There is a direct relationship between sine of angle A and the side opposite of it, which is little a. Do you see here sine of angle A and opposite of it? That is equal to sine of angle B and the side opposite of B, which is little b, okay? Look here, see, opposite of angle B is little b. And then it's also equal to sine of angle C over side C, which is the side opposite of angle C, okay? I know this might look really strange, but here's what we're going to do. We're not going to set up like a three-way proportion. We're only going to use two ratios, but we need one complete ratio and then something that's missing in the other one. And then we'll look at some examples and hopefully it'll make a little bit more sense. Here we go. We're going to find some missing sides and angles using the laws of sine. Laws of sine. We're going to set up a proportion and solve for x. Here is x, okay? So first I notice I have 35 degrees and opposite of 35 degrees is 12. So sine of 35 degrees over 12 is equal to sine of the opposite angle, the other angle opposite of the side we're missing, right? You see how 71 is opposite of side x, so we'll set up that proportion. Okay, now our proportion is complete. We are going to cross multiply x times sine 35 is equal to 12 times sine of 71. All right, we need to solve for x, so we're going to divide both sides by sine 35. Okay. So this is what we put in our calculator. We're going to get out our calculator and we're going to type in 12 times sine 71. Be very careful that you close the parenthesis, because once you press the trig function, it opens a parenthesis. You want to close it. Then you hit the divide sine 35. Enter. And we're going to round to the nearest tenth. Okay, so this is going to be 19.8. X equals 19.8 here. All right, let's have a look at example 2, okay? So since we know there is a direct relationship between an angle and the side opposite of it, I want you to look for that right away. When you're trying to find a side, I want you to look for a complete angle and a side opposite of it, right? So sine of 18 over 5, that would be your first ratio, because that's the angle, sine of the angle over the side opposite of it, is proportional to sine of the other angle, so sine of 114 over x. That's like the hardest part. And then you cross multiply. So x times sine 18 is equal to 5 times sine of 114. 114. All right. Okay, now we just need to solve for x, so we divide by sine 18. Once you do a couple examples, it definitely gets easier. I know the first time I saw it, I was like, what is this? This is so weird. But math is pretty cool. All right, my 8 looks crappy. All right, so now remember, this side of the equation is what you're putting in your calculator. So we said 5 times sine 114, close the parenthesis, divided by sine of 18. Enter. I get 14.8 if I round to the nearest tenth. X equals 14.8. Oh, I went out of room there. Okay, so I'm going to give you 2 problems in the next slide, or maybe 4, to try on your own, okay? So I want you to write these problems down, pause the video, see if you can set up the proportion and solve correctly. And we want to round to the nearest tenth, okay? That's 1 decimal place to the right. All right. All right, cool. So hopefully, you got number 3 right for sure, because number 3 just followed the last 2 examples we just did. We set up our proportion. Our first ratio must be complete. Sine of an angle over the side is equal to sine of the angle opposite the side I'm looking for. So we need to make sure we have that angle. If you notice in 4, 5, and 6, we didn't have the angle given opposite of the side. But recall that any triangle, no matter how big or small, the interior sum is 180 degrees. So you should have been able to take 180 minus 53 minus 96 and get that this angle measure is 31 degrees, which is opposite of side X. So first our proportion should be, our first ratio, sine of 96 over 27 equals sine of 31 over X, cross multiply, and we get 14 for the missing side. Down here in number 5, same thing. We were missing the angle opposite of the side. So I had to subtract from 180. I get 48 degrees here. So the side I'm given is 15. The angle opposite of that is 29. Sine of 29 over 15 is equal to sine 48 over X. We get X is 23. Number 6, same thing. Subtract, we get 89 degrees. Sine of 58 over 25 is equal to sine of 89 over X. Cross multiply and we get X is 29.5. So hopefully you did well and you were able to come up with 4, 5, and 6 and figure out what was missing there. Just checking it out, All right, let's take a look at some more examples here. All right, here again, I have all right, so I see sine of 23 over X, but I need to know what this angle is over the given side I have. So if I subtract from 180, I get that it is 40 degrees here. So now I can set up my proportion. Sine of 40 degrees over 29 is equal to sine of 23, oops, I don't know why I wrote 2, over X. Right, we cross multiply, we get X times sine of 40 is equal to 29 times sine of 23. To get X by itself, we simply divide. We plug this in our calculator, 29 times sine 23, close parenthesis, times sine of 40, divided by sine of 40, round to the nearest tenth, equals 17.6. All right, number 8, exactly the same. Let's just have a look here. Actually, why don't you pause the video again and see if you can get this one on your own and check your answer in a minute. All right, so for number 8, you should have realized the missing angle measure was 80 degrees, set up your proportion, and get X equals 11.5. All right, now we're going to switch gears just a bit because for the first 8 examples, we were just finding a missing side. Now, we're going to be finding a missing angle inside the triangle. So I want you to think about inverse functions, okay? Because we're looking for something inside. So the first step is always the same. We are looking for sine of an angle and the given side opposite of it that's given, all right? That has to be there, otherwise we cannot use the laws of sine. So sine of 77 over 14 is equal to sine x over 9, all right? The setup is exactly the same, right? What we're looking for over what we have for that second ratio. Now we also still cross multiply. So 9 times sine of 77 is equal to 14 times sine x. All right, so now we need to get x by itself. So what we are going to do is we're simply going to just divide by 14. All right, and here is what you're going to do. You're going to use inverse sine because we're looking for an angle. So we're going to do sine inverse of 9 times sine of 77. Make sure you close that parenthesis before you divide by 14. All right, when we put that in our calculators, right, we hit second sine inverse 9 times sine 77, close parenthesis, divided by 14. And I round to the nearest tenth and we get about 38.9 degrees. 38.9 degrees. Okay, that wasn't terrible. Okay, I think we can do it. A little practice, just like everything else, you know, when we. Oh, I'm sorry. Why did I say 0.9? It's 0.8. It was 38.78. What a silly goose. 38.8 degrees. I'm sorry. If you were thinking, Mrs. Garcia, I got a different answer. You're right, because this is the right one. All right, let's look at another example. Get a little more practice under us, right? We are always looking for the angle and the side opposite of it first. So sine of 126 over 31 is equal to sine x over 15. So now we have our proportion all set up. We're just going to cross multiply. Bingo, bango. I'm going to go this way this time because I always like my variable on the left side. So 31 times sine x is equal to 15 times sine 126. Divide both sides by 31, right? Because we're trying to get sine x by itself. And this is what we put in our calculators. Inverse sine first. So inverse sine of this quotient. So second sine, 15 times sine 126, close parenthesis, divided by 31, enter. Round to the nearest tenth. I'm going to try not to mess it up, but I get 23 even because it's 23.045, but the 4 doesn't make the 0 go up, so it's just going to be 23 degrees. X equals 23 degrees. Beautiful. All right, cool beans. All right, so I have 4 more examples here using the laws of sine to find angles. I'm going to do 2 more with you, and then you can pause and check to see how you're doing for number 13 and 14 to see if you get it, okay? So we always start the same. So here I have sine of 61 over 24 is equal to sine x over 21. Cross multiply, I get 24 sine x is equal to 21 times sine, oh my goodness gracious, that was bananas, sine 61. All right, we divide by 24 to get sine x by itself. Remember, we're using inverse sine of this right here, inverse sine. Dink. All right, plug that in, my baby boy right here. Inverse sine, 21 times sine 61, close parenthesis, divide by 24, and I get 49.9 degrees. X is equal to 49.9 degrees. Fabuloso. All right. One more for the people. We have sine of, oh my gosh, I'm trying to write smaller, but it's really hard to do. So here we go. Big print. Sine of 25 over 12, right? Because that's given. We have to use that given. And we set up our proportion, sine x over 28. Then we do our cross multiplication, 12 sine x equals 28 sine 25. Divide by 12. And we're going to get, remember, inverse sine, because we're looking for inside the triangle. Inverse inside. Do not forget, or you will get the wrong answer. All right, so when I do inverse sine of 28 times sine 25, close parenthesis, divided by 12, I get 80.4 degrees. 80.4 degrees. Beautiful. All right, so why don't you guys pause the video right now, copy down 13 and 14, solve them on your own, see if you know what you're doing before we talk about the laws of cosine. All right, hopefully you set up your proportions right and you got 59.1 degrees for 13 and 22.7 degrees for number 14. All right, so now we're going to switch gears. Make sure you have a clean sheet of paper because we're going to talk about the laws of cosine. Okay, so sine, we set up proportions, the laws of cosine. There is a relationship between angles and their sides, but it's going to be a different setup. Okay, so prepare yourself. It's a little overwhelming at first. All right, so given this triangle here, just like the laws of sine, the laws of cosine can be used to find side lengths and angle measurements for any triangle, not just right triangles. So I'm going to show you, the old generic formula that, mathematicians like to use a lot, and it sometimes overwhelms people, but sometimes people love to see it. So if we are looking for side A, let's say we're looking for side A, we know that A squared is equal to the other two sides squared added together minus 2 times those two sides times cosine of the angle opposite the side I'm looking for. I know, you're like, what? That's crazy. But there's a pattern, and you're going to get used to it because you're going to practice. Don't freak out. Let's say we're looking for B. Well, we know that B squared is equal to A squared plus C squared minus 2 times A times C times cosine of big B. All right, now I bet you can kind of guess what's going to happen if I'm looking for side C. C squared is equal to A squared plus B squared minus 2 times A times B times cosine of big C. All right, that's the law, that's the rule, that's the stuff. Copy it down. You should copy it down. All right, basically A, B, and C are the missing sides when we're looking for sides. And then when we're looking for angles, we're also gonna, like if we were looking for this angle, we would start with the side opposite of it and then solve. We would slowly peel it like a banana, right? You don't just like squeeze a banana and eat it, you gotta peel it first, okay? All right, let's look at some examples. First off, obviously I'm looking for x. That's gonna be my first. So I'm gonna say x squared is equal to 7 squared plus 12 squared minus 2 times 7 times 12 all of that times cosine of 65, because 65 degrees is opposite of the side I'm looking for. Do you see it? Right there, okay? So now what you need to do is you need to just plug this whole thing in your calculator one time, okay? So, I know that x squared, well, I don't know what that is yet, but I gotta figure out, so 7 squared plus 12 squared minus 2 times 7 times 12 times cosine 65. Enter. I get, if I round to the nearest tenth, I get 122. Right? To unsquare something, we take the square root. I'm not going to ask you to put this in radical form. It is okay to have decimals here. So when we take the square root of 122, I get 11. Duh. It's a perfect square. But that's the laws of sine. I mean cosine. Please forgive me. Please. All right. Let me do another example for you. Now, you see the side you're looking for. You're looking for x. So that's the side I start with. So x squared is equal to 25 squared plus 20 squared minus 2 times 25 times 20 times cosine of 108. This is where you get out your fancy little calculator and you just plug that bad boy in. Right, I get 25 squared plus 20 squared minus 2 times 25 times 20 times cosine of 108. Round to the nearest tenth, and I get 1,334. Oh, x squared equals that. Remember, we need to take the square root then. That's not our answer. So we take the square root of that, and we get 36.5. 36.5, that's what x is. Beautiful. Okay, so hopefully you feel a little better about it. Okay, it's really literally not as crazy as these formulas make it seem. It's not so bad. So right now what I want you to do is pause the video again. I want you to set up, you're using the laws of cosine, and solve for x for 3 and 4. All right, hopefully you found that not too terrible, right? You're just basically plugging all of this into the calculator, taking the square root, and you're good, okay? So you should have got 9.6 for number 3 and 24.1 for number 4. Now, let's take a look when we're missing the angle. Here's where things have to take a tiny bit of a turn. We do have to do a little bit of work. So first you want to look for the side opposite of the angle missing. That's the side we start with. So 7 squared is equal to 12 squared plus 11 squared minus 2 times 12 times 11 times cosine, oops, I'm sorry, cosine of x, okay? What we need to do is we're gonna peel this banana, right? We're gonna basically separate the equation right here. So just like draw yourself a little line there and separate it. You're gonna calculate 12 squared plus 11 squared. So 12 squared plus 11 squared is 265. So this is 265. You should know that 7 squared is 49. That's what's on this side. If we figure out what negative 2 times 12 times 11 is, that's negative 2 times 12 times 11. On this side, we have negative 264 cosine x. First thing you're going to do is subtract this 265. Right, that's gone there. 49 minus 265 is negative 216. That is equal to negative 264 cosine x. Okay, remember, we're looking for an angle inside the triangle. We're going to use inverse functions in the end. I need to get cosine x by itself, so I'm going to divide by negative 264. Okay, here, this right here is what you're going to put in your calculator in inverse cosine. So first you're going to take out your calculator and you're going to be like, all right, second cosine negative 216 divided by negative 264. Okay, if you know that a negative over negative is a positive, you could have just put in positive 216 divided by 264 and get the same thing. But what I get when I round to the nearest tenth is x is equal to 35.1 degrees. $35.1 degrees. That wasn't terrible. I hope not. All right. Let's look another example here. Okay. I'm looking for x. I'm going to start with the side opposite of it. So 35 squared is equal to 16 squared plus 24 squared minus 2 times 16 times 24 times cosine of x. Remember, that's what we're looking for, cosine of x. This is where you need to separate the equation. Okay, right here, right in front of that negative sign or that minus sign. Separate it. First, we calculate 35 squared. That's 1,225. Then I figure out what 16 squared plus 24 squared is. That is 834. I mean 832. I don't know what's going on. All right, now we can figure out what negative 2 times 16 times 24 is. Definitely going to be negative, right? Negative 2 times 16 times 24 is negative 768 cosine x. All right, we separate this because I don't want you adding this into anything, right? This is multiplication. In order to get cosine x by itself, we have to divide this coefficient. But we do want to subtract this 832 over because that's how we solve equations. We start with addition, subtraction, and then we work our way down the chain. All right, so 1,225 minus 832 is 393. That is equal to negative 768 cosine x. All right, we need to divide by that negative 768. Remember, we are looking for an angle inside the triangle, so we're going to use cosine inverse of that quotient. So cosine inverse of 393 divided by negative 768 is 122.8 degrees. So I get x is equal to 122.8 degrees. All right, so I'm going to let you practice using the laws of cosine to find the missing angle on these two problems, and then you will be free. So please pause the video, copy them down, try to solve them, see if you know what you're doing. And if you don't, you better ask me some questions because that's the only way I'm going to be able to help you. All right, pause that video. All right, so for number 7, you should have got 53.8 degrees. For number 8, you should have got 32 degrees even, because you round to the nearest tenth. It's, sorry, I just swallowed wrong. 32.03. So just 32 degrees is fine. All right, if you need to, rewatch the video. But here is your homework for tonight. Assignment number 40. It's a worksheet. What? You'll be practicing both methods, laws of sine and the laws of cosine. This is a little hefty. There are a total of 24 problems on here. I really hope you guys try your best to complete them all on your own. And please let me know if you have any questions, and I'll see you soon. Have a great day. Bye.